This is Taco Tuesday presenting Trinidadian Tacotron 2, a text-to-speech model and assessment package for Trinidad and Tobago. Well, my group consists of Rajiv Sadhu, Tariq Mohammed, and myself, Daniel Rashid. So our problem centers on the use of deep learning text-to-speech system called Tacotron 2. And it is used to first generate synthetic speech, and then we aim to evaluate the quality of the productions using standard speech analysis algorithms. You see, Tacotron 2 is capable of producing a natural sounding human speech from annotated speech dataset as compared to its predecessor, Tacotron 1. Our project will seek to generate speech clips of specific text and different training quality levels, and to conduct objective evaluation experiments using 5 speech analysis algorithms. So what is the significance of our project? Well, you see, in the Caribbean, as usual, we are usually the last to get anything. So the technologies are out there and they currently exist, but they have not been applied to Caribbean accents. And yes, the objective analysis algorithms are out there, they exist, but they aren't in an automated pipeline such as this. Now we will go over to Rajiv, where Rajiv will tell us about Tacotron 2.
So we use Tacotron 2 as the text-to-speech synthesizer for this project. What Tacotron 2 does is it takes written text and then converts that to Mel spectrograms, which are then converted into wave files that synthesize Trinidadian speech. We trained it on female speech. So we have a model that produces Trinidadian female accented speech.
Right, so the analysis pipeline. The question that I ask is, how do you exactly measure the quality of a synthesized voice? So from our research, we have found 5 algorithms that we have decided to wrap into an API and a GUI that will measure and compare qualities of a synthesized voice, such as the frequency of the voice, the jitter of a voice, breathiness, the length of the wave sequence, and even a difference in pitch. And this allows us now to get an educated calculation on how close to a natural sounding voice we can actually synthesize. So what is in this pipeline? Well, the first of the algorithms that we use to analyze the quality of the sequence would be the Mel-Cepstral distortion, or MCD. What is MCD? MCD is a measure of power spectrum of sound in 2 sequences. In basic terms, it measures the frequency of 2 sequences. Then we have banda periodicity. Banda periodicity is an algorithm that measures the characteristics of noise or the characteristics of a voice. You see, a periodicity is responsible for distortion, raspiness, breathiness, jitter, shimmer, even a tremble in your voice. So I'll move over to Tariq now, who's going to further explain what is in our pipeline. Tariq?
Right. So the third algorithm in the pipeline would be frame disturbance. That describes the alignment part of each individual frame or point in speech between the reference and the synthesized voice models. So it essentially measures the distortion of the synthesized speech and the alignment to the actual audio file, whereby a larger frame disturbance value would indicate poor modeling performance and a smaller value would be more favorable. The fourth algorithm in the pipeline would be error of frame voicing prediction. And that gives a percentage of the number of voice frames that are marked as unvoiced and the number of unvoiced frames that are marked as voice. Essentially, the voice frames correspond to sounds where you are able to feel a vibration in the vocal cords, whereas unvoiced frames do not. Next slide, please. Right, the last algorithm would be root mean square error, which measures the standard deviation of the residuals or the prediction errors in the audio file. It involves the use of the fundamental frequency F0, where it compares the value between both real and synthesized voice models and essentially gives a comparison of the pitches between both audio files to determine how well the model was synthesized. Right? So who does this project benefit? The project would benefit virtual assistant developers or persons who often use text-to-speech models as components in their projects, as they would be able to easily test the quality of the synthesized voices. It would also benefit consumers of virtual assistants indirectly, as they would now be able to receive higher quality products due to the improved text-to-speech model integrated in the products. Lastly, the project would benefit future developers and researchers in the field of speech synthesis, as it would leave a base platform to analyze the quality and closeness of a synthesized sequence to an actual spoken sequence. This leaves room for further additions in the form of emotional vocal speech to the text-to-speech model. Next slide, please. Okay, so the pipeline flow now. Essentially the flow of the pipeline would be that the user inputs a CSV file which contains the paths to the different real and synthesized audio files. The CSV file would be processed and it converts these files to a NumPy array, which goes to the controller to essentially get the results from the 5 different algorithms and outputs it as a CSV file as well as to a GUI output. Sorry.
All
Next
right.
slide, please.
Thank you, Tarek. So let me play two sequences for you of the same line, and you tell me which is better.
As the taps upon her shoulder are repeated, she stretches out her long neck and with long strides makes for the eastern horizon. As the taps upon her shoulder are repeated, she stretches out her long neck and with long strides makes for the eastern horizon.
So this is the difference between Tacotron 1 and Tacotron 2. Tacotron 2 was trained, both Tacotron 1 and 2 were trained with Trinidadian and Jamaican dataset. However, with Tacotron 2, we can now detect the Trinidadian accent flowing a little bit more than in Tacotron 1. Now let's move over to our demo. Rajiv, take us away.
Okay, now we'll be looking at Tacotron 2 and our deployment on ANIs. So deploying Tacotron 2 was a bit of a hassle. We had to wrap the model in a Flask app, which we adapted from the Koki text-to-speech built-in model, because they had included one as well. Now, this is the end result here, which we've deployed on ANIs. It's inside of a Docker container with another Docker container that has the models in it, because they're quite big files, right? So this is on ANIs itself, and this is on the endpoint. Now let's generate some sentences. Now, this is the female voice. The male voice didn't pan out quite well, so we won't be showing it off today. So let's see. Hello there.
Hello there.
It's a bit noisy, but you can still tell that it's quite Trinidadian. Let's have a longer sentence there. Right? So the model
Hello there, how are you doing? I am well.
The model splits it up into sentences based on punctuation. Right? Now, one thing we noticed was that because of how the model was set up, we can actually get Trinidadian dialectal spelling understood. So
Hey, check thing.
yeah, so as you can see,
You feel our cars speak freely.
it's not perfect, but it does work much better than we originally intended it to, since we didn't cater for this at all. Now, as you notice, some parts aren't generated perfectly, and that's because we were lacking some data. We had a very small data set to work with. So it's not perfect, but it is a pretty good representation. And let's take one more and see how it performs.
What goatishness is this?
See, pretty decent. And this is how Tacotron 2 performs.
We are here now at the pipeline. Our pipeline takes in a CSV file, or it also takes in WAV files. So we have a couple options in our pipeline. Our tabs here show us exactly what we do. So the first pipeline just analyzes with using all 5 of our algorithms. And if you want individual, sure, you can do individual. So let's do individual, right? Let's find the malceptual distortion of a sequence. So first thing first, we need our real sequence, and then we need our demo, our synthesized sequence, and we submit our WAV files to the algorithms to be, and there we go, calculated. So 32.6 is a rather good malceptual distortion value. Each of the different algorithms, they contain different values, and we have standard values that you will find in our documents.
Right, so future plans. So we essentially are gathering more data to implement a proper multi-speaker model, and we could also integrate with other technologies to provide additional text-to-speech.